Hello, my name is Deja Malone-Persha, and I'm the Plants Program Manager for the Salmon River Restoration Council, which I'll be referring to as SRRC. Today, I will be sharing case studies of in-stream restoration and riparian revegetation in the Salmon River watershed. Located in Northern California in the ancestral territory of the Karuk, Shasta, and Konamihu tribes, the Salmon River is the second largest tributary to the Klamath. In the last 170 years of European settlement, the watershed has been significantly impacted by industry and land management decisions. Today, the legacy impacts of hydraulic and dredge mining, logging, and fire suppression have altered the hydrology, geomorphology, and ecology of the river. The river channel has been simplified, the bed material coarsened, the banks armored, and there are now fewer inputs of large woody debris. As a result, this loss of quality habitat has impacted the anadromous fishery, including populations of coho salmon and spring Chinook salmon. In 2005, the Salmon River was deemed to be temperature impaired. All of these factors combined spurred a watershed-wide analysis to determine which sections of the river would benefit from shade recovered through revegetation. A list of sites with high riparian restoration potential emerged from this effort. Coupled with a later analysis of fish habitat and fish passage barriers, the three in-stream restoration projects that I will discuss today were identified as priorities. These projects focused on restoring aquatic habitat, though all of them also featured riparian revegetation. A revegetation plan was developed for each, guided by the following objectives: provide structural complexity, diversity, and shade, provide stream inputs of woody debris and organic matter, and reduce the abundance and distribution of non-native invasive plant species in the project areas. I will provide an overview of our revegetation approach within these three different projects, including two that aim to reconnect the floodplain, the North Fork Salmon River, and one that improved fish passage on the South Fork. Two of these projects are in the post-construction monitoring phase, and the third is planned for implementation in 2023. Our approach to riparian revegetation has evolved over the course of our projects. In each one, we have attempted to use a revegetation method that we've not yet worked with. I'll share our experience with noxious weed treatments, installing brush baffles, augmented planting zones, broadcast seeding, and our plans going forward using a data-driven revegetation method. I don't plan to speak too much on our limited application of shrub salvage, but it is a method that many practitioners use in projects of this kind. The Kelly Bar Habitat Enhancement Project was implemented in 2019. This 12-acre project enhanced existing high-flow side channels, provided 2 off-channel ponds and alcoves to provide habitat for multiple life stages of salmonids. Revegetation elements were a central design feature on the alluvial bars in the project area. In the aerial image on the left, take note of the limited riparian vegetation prior to construction. On the right, you can see the side channels, off-channel ponds, and alcoves, which were enhanced on both sides of the river. From above, you can also see brush baffles lining the side channels, as well as the mulched augmented planting areas. In fact, SRC has been restoring vegetation throughout the site for over 2 decades. In 1997, the Class A species, spotted knapweed, was discovered on the Salmon River with the epicenter situated at Kelly Bar. Once discovered, this infestation of spotted knapweed became known as one of the largest in the state of California. For the past 24 years, SRC has led a rigorous non-chemical treatment effort to control the species throughout the entire watershed. Within the first 10 years of non-chemical treatments at Kelly Bar, there was a 99.5% reduction in population size. Over the past 6 years at the site, we've located and treated fewer than 10 plants per year. While other organizations may not have 24 years to devote to this kind of pre-treatment, I share this success of ours to encourage others in this pursuit. SRC has also been managing Dyer's woad, a Class B species, and Himalayan blackberry on site, and will continue as long as funding allows. Given that significant ground disturbance occurs in projects of this kind, we incorporate project design features like equipment cleaning procedures to minimize the possible spread or introduction of noxious weeds. In this case, the access road was shortened, reducing future travel across the main bar, and a cattle exclusion fence was constructed to prevent livestock from entering the site. During construction, heavy equipment lined the channels with willows, built willow brush baffles, and 12 augmented planting zones. For the baffles, a long and deep trench was excavated to intersect summer groundwater, which was between 8 and 10 feet deep. Wood chips and chunks were added to the bottom of the trench to retain water, and then live willow stakes were placed with their bases in the water table. The baffles will provide resistance to help direct flow during high flow events and will also revegetate the bar. The banks of the side channels and pond outlets were also enhanced with live willow stakes installed in a similar manner. As for the augmented planting zones, on average, 25-foot diameter pits were excavated to the summer groundwater depth. Battered logs were placed into the pits with their base submerged in the groundwater along with slash. These pits were then backfilled with a mixture of the best soils and fines found on site and then mulched. The goal is for the logs to behave like a wick, transporting groundwater into the planting zone. Once construction concluded in the fall of 2019, we planted a diverse array of native shrub and tree species throughout the site, within the augmented planting zones and in other areas with favorable conditions. 2 years of vegetation surveys demonstrate successful establishment. First of all, our persistent spotted knapweed treatments over 24 years have yielded a marked reduction on site. This river bar complex once hosted over 120,000 plants. And despite the ground disturbance caused by this project, we only found 2 individuals in 2021. Vegetation surveys indicate moderate to high success with our willow and container plantings throughout the site. In 2021, we had 63.3% survival of the approximately 4,000 live willow stakes. As for our container plants, in 2021, we had 87.2% survival. We irrigated a subset of our planting zones. However, we did not observe significant reduction in mortality in those areas. We have observed natural recruitment throughout the project of native forbs, trees, and shrubs. Species observed include tidy and miniature lupin, turkey mullein, Oregon sunshine, scarlet monkey flower, yerba santa, manzanita, willow, and alder, to name a few. Now I'd like to speak about our most recent work in the Hotelling Gulch Aquatic Restoration Project. Implemented in 2020, this 3-acre project was designed to improve fish passage, opening 1.4 miles of stream habitat. We rerouted the stream into its historic channel and replaced undersized culverts with a bridge that will withstand a 100-year event. This project enhanced channel complexity and provided alcoves for temperature and velocity refugia. As you can see from the aerial image on the left, we installed augmented planting zones along the restored stream channel. Additionally, we've managed 2 high-priority noxious weeds on site, Dyer's woad and yellow star thistle. We've incorporated live stake willows along the stream and used 2 methods to broadcast seed the entire site. This project featured augmented planting zones with the same design, but on a smaller scale as those constructed at Kelly Bar. The revegetation plan incorporated native shrub, tree, and herbaceous species in this case. The microsite conditions in each planting area then informed the planned species composition. Within both Kelly Bar and Hotelling, we designated certain planting areas dry sites and others riparian. In this project, those positioned around the alcoves, pictured above, have surface water year-round and tend to be wetter, whereas the sites positioned above the stream are drier as the stream goes subsurface in the summer. Those are pictured below. Container plants were planted in late 2020. For those of you interested, these are the species we planted in our 2 projects. Those highlighted in yellow were incorporated at both sites. When selecting our species, we considered presence and distribution within the watershed, regional nursery availability, and then we developed assemblages that will provide structural complexity and stream inputs. Species like Doug fir and incense cedar were selected to provide future inputs of large woody debris, and species like white alder and big leaf maple were selected to contribute stream inputs of organic matter in the form of leaf litter. As for our willow species, we've collected primarily from coyote and arroyo willow. This past year, we applied a revegetation tool new to us. We decided to hydroseed the majority of the Hotelling site. Hydroseeding was accomplished over 2 passes. The first applied the native seed mix with a tackifier, and the second pass spread hydrocompost, which appears brown in the upper photo. At SRC, we've been expanding our capacity for native plant materials programming. We also decided to direct seed a small subsection of the site by hand with a diverse mix of locally sourced herbaceous seeds that SRC had collected. In our hoteling project, we've had lower success rates with our willow and container plantings, as well as with our broadcast seeding. Few live willow stakes at the site have survived. The best survival has been in the lower portion of the channel and around the alcoves where perennial water flows. As the upper stream surface goes subsurface in the summer, it may constrict underground, leaving our streamside willows outside of the flow path. Important to note is that we did not irrigate in this project due to low stream flow. This past year, we also experienced prolonged extreme heat and drought conditions. We believe that the low survival of our container plantings can be attributed to these combined factors. Finally, our broadcast seeding yielded marginal germination throughout the site. We had overall poor summer survival of the seed that germinated in spring of 2020. That being said, we are seeing a green up after the recent storms and remain optimistic. This water year has already surpassed that of early 2021. This past fall, remaining funds enabled us to replenish our planting zones with container plants and do additional broadcast seeding in priority areas in the site. Looking ahead, we are finalizing the planning phase of our red bank habitat restoration project. Learning from our previous projects, we're eager to begin implementation to restore the floodplain here in 2023. It will be our largest project to date, spanning a total of 30 acres. We will enhance the side channel complex, roughen the channels with large wood structures, and provide temperature and velocity refugia throughout the site. We now have 2 years of invasive species treatments under our belts, addressing Dyer's woad and yellow star thistle. For this project, we consulted with McBain Associates to develop a robust revegetation plan. This project will incorporate reveg methods that we now have experience with, including augmented planting zones at 2 different scales, willow planting and brush baffles, as well as hydroseeding. In order to develop the revegetation plan, McBain Associates used a data-driven method developed and discussed by Baer et al. In the journal Ecosphere. In order to develop the revegetation plan, SRC conducted pre-construction vegetation surveys to classify and map dominant cover types throughout the site, pictured on the left. These surveys also captured the substrate and disturbance interval for each cover type. McBain Associates then developed a detrended digital elevation model using LiDAR and bathymetry data collected by Mike Levin Associates in 2015. The cover types were then overlaid and analyzed for their elevation above the river and the presumed shallow groundwater height. The cover types were then associated with a habitat zone depending on their respective elevation: emergent, riparian, transition, or upland. The revegetation plan developed by McBain Associates adjusted for the planned restoration actions throughout the site, identified augmented planting zone types, locations, and species assemblages appropriate for the habitat zones in the project. By using this data-driven method to design our revegetation plans going forward, we hope to improve our approach and achieve our goals of restoring both the aquatic and terrestrial habitat within our sites. Pictured is the side channel complex, which will be enhanced with large wood structures and alcoves. Our revegetation work has evolved over the years and will continue to change as we learn from our past projects. It will take time to determine whether our revegetation has been successful in the long term. It's crucial that we consistently monitor these sites, both prior to and following implementation, to evaluate our methods. We're committed to consistent surveys and increasing our capacity to monitor these projects with increasing depth. The experience that we now have through planning and implementation will continue to inform our work. The crux that we've encountered now is sourcing genetically appropriate native plant materials. If all goes as planned, we aim to collect a portion of the native seeds and cuttings to be used at Red Bank from within the watershed. We have promising leads with a few local nurseries that would be able to facilitate projects of this scale. There are many advantages to collecting our propagules within the watershed and having them grown locally. The species and subspecies would be appropriate, they would have diverse genetics, and would be adapted to the climatic conditions within the Klamath Mountains. Furthermore, by working directly with local nurseries, we hope to support our rural economy and minimize the use of materials from outside of the broader Klamath Basin. We're also cognizant of forest pathogen introduction and spread in nursery settings that can then be introduced into wildland settings. It's our hope that by providing the materials for grow out and working with local nurseries with best management practices, that this threat is diminished. Our work would not be possible without the support of others. We're tremendously grateful for those that have been involved over the last 30 years. I appreciate your interest in our restoration efforts. If you find yourself in the Salmon River, please reach out. We welcome you to visit this botanically rich and ecologically dynamic watershed. Thank you.